Okay, so we have number 48, trapezoids and kites. What are some properties of trapezoids and kites? We're going to recognize and apply properties of trapezoids, including medians, and properties of kites. So, some vocabulary before we begin. A trapezoid is a quadrilateral with exactly one pair of parallel sides. Can you all on the computer see the screen? Okay, because I don't see the green box. Okay. The parallel sides are called bases. The non-parallel sides are called legs. So regardless of if your trapezoid is oriented like this one that you see down here in the bottom right corner, or if it's turned, whatever sides are parallel, those are always going to be the bases, okay? The base angles are formed by the base and one of the legs. So in this trapezoid ABCD that you have, angle A and angle B are one pair of base angles, and then angle C and angle D are another pair of base angles. Okay, so two sets of base angles. So if the legs of a trapezoid are congruent, then it is an isosceles trapezoid. So if the sides that are not parallel, if those are congruent, then it is an isosceles trapezoid. So first card. If a trapezoid is isosceles, then each pair of base angles is congruent. So here's trapezoid FGHJ. Angle G is congruent to angle H, and angle F is congruent to angle J because this trapezoid is isosceles. And we know that it is isosceles because of these lines that are here, which are telling us that GF and HJ are congruent. Okay, so if it's an isosceles trapezoid, base angles are congruent. Next, if a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. So the converse is true involving the base angles. And then the third card says that a trapezoid is isosceles if and only if its diagonals are congruent. So an isosceles trapezoid has congruent diagonals. This is trapezoid QRST. It is isosceles. So QS is congruent to RT. And those are your diagonals for the trapezoid. Okay, so in an isosceles trapezoid, diagonals are congruent. Okay, first example. Here's a basket. Each side of the basket is an isosceles. Each side of the basket is shown as an isosceles trapezoid. So the measure of angle JML is 130, KN is 6.7, MN is 3.5. What's the measure of MJK? So let's look at it. Let's see here. Okay, so the first thing it tells us is that angle JML is 130 degrees. So that's this angle right here. Let me pick a different color to make it easier. That's this angle right here, and it's 130. Then they tell us that KN is 6.7. So this is 6.7. And MN is 3.6. Good morning. Okay. And then they want to know what's the measure of MJK. So what is the measure of this angle? Okay, so if this is an isosceles trapezoid, there's some other things that we can put on here as well, right? So if it's an isosceles trapezoid, we know that these two sides are parallel, right? And we know these two sides are congruent, okay? So what can you tell me about the measure of, what can you tell me about the measure of angle MJK? Which is that one where I have the question mark. What can you tell me about MJK? It's going to be equal to LKJ, so it's going to be equal to this one here. So I'm going to put 2 here. All right. So let's think through it, okay? So this one is 130, right? So that means down here, the other base angle is 130. So we got 130 plus 130. I do not know how mine sideways like that. And that's equal to 260, right? This is a quadrilateral. What's the sum of the interior angles of a quadrilateral? So the sum of the angles has to be 360. So I'm going to take 360, and from 360, I'm going to subtract 260, bless you, because I already have 260. That's going to leave me with 100, right? If this is an isosceles trapezoid, then that means that base angles are congruent. So that means that these two angles have to equal 100, but they're congruent. So this angle has to be 50. Okay. Questions? So we're using information that we already had from previous. Okay. Can I erase this? All right, so the next one, same image. That's right. So the next one says, same information, but this time we now need to find JL. Maybe I shouldn't have erased it so quick. Okay, but we're talking about lengths now, so let's just put the lengths on here. So it says that KN is 6.7. And it says that MN is 10.3. Right, and so now we need to know JL. Well, how long is JL? So JL is the same as KM, right? And what is KM? 10.3 plus 6.7, right? So that is 17, right? So JL is 17. Make sense? Questions? All right, let's keep it moving. Let's see. All right. So quadrilateral A. Ooh, y'all, I hate that. Let me fix that. Oh, I hate that so much. Do y'all hate that too? Like when it's broken up? Yeah, man, I hate that. All right. Quadrilateral ABCD has these vertices. Show that ABCD is a trapezoid and determine whether it's an isosceles trapezoid. So, how do we show that it's a trapezoid? What has to happen if it's a trapezoid? I can't hear you. The bases have to be parallel. So the first thing we need to show is parallel bases, right? Okay. So we're going to show parallel bases. Okay. So where are our bases? Our bases are going to be CD and B, but BA, right? Okay. So so in order to show that the bases are parallel, what number do we have to have? Slope. Okay, so the slope of CD is what? Let's just count. We're gonna rise 1, 2, 3, 4, and the run is 4, right? So 1/4. Do we agree? Okay, and then the slope of BA, we're gonna go up 2 and over 1, 2, 3, 4, 5, 6, 7, 8. So it's gonna go up 2 and over 8, which means that slope is 1/4. Is that all we need for a trapezoid? Is that all we need for a trapezoid? Now, do the legs have to be congruent for it to be a trapezoid? For it to be isosceles, absolutely. But for a trapezoid, no. Because let's look. Get back on my mouse. And it's going to be kind of messy for a minute. A trapezoid has exactly one pair of parallel sides. Do we have one pair of parallel sides? Yes. So is there anything else that we need to have for a trapezoid? Absolutely not. So now there are a couple of things for isosceles. So if it's isosceles, the legs have to be congruent, or what else can we have? Base angles, but that's not something that we could calculate angles, right? But we could also calculate the diagonals, because if the diagonals are congruent, then it could also be a isosceles trapezoid. Okay, so when I look, do we want to do the distance of the sides, or do we want to do the distance of the diagonals? It absolutely does not matter, but let's just do it pretty quick. Okay, so let's go ahead and do the sides. So we're going to do CB. Oops. So CB is equal to the square root of -3 minus -2 squared plus -1 minus 3 squared. That's going to be -3 plus 2, which is -1 squared, which is 1. So that's 1. -4 squared is 16. Plus 16, that's going to be the square root of 17. Did we all get the square root of 17? Now let's do AD. And so that's going to be the square root of 2 minus 5 plus 4 minus 1. So 2 minus 5 is -3. 3 squared is 9. So that's the square root of 9. 4 minus 1 is 3. 3 squared is 9. So 9. So that's going to be the square root of 18. So is this an isosceles trapezoid? No, because the numbers do not match. Questions? Questions over here on the computer? All right, moving on. The mid-segment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoids. So if I have the legs, then this point here and this point here, those are both midpoints. So connecting those, that would be the mid segment. Okay. So the mid segment of a trapezoid is parallel to each of the bases, and its measure is 1/2 the sum of the lengths of the bases. 1/2, I knew I was going to do that. 1/2 the sum of the lengths of the bases. I'll say that again. 1/2 the sum of the lengths of the bases. All right. So in this particular trapezoid, AF and CD are the bases. So this one is oriented differently, but because those are the two sides that are parallel, then AF and CD are the bases. And so then the length of BE is 1/2 of the sum of AF and CD. So let's put that to practice. All right, so in this figure, MN is the mid-segment of trapezoid FGJK. What is the value of X? What is the value of X? So MN is the mid-segment, right? So just to keep with our formula, we know that MN is equal to 1/2 the sum of KF plus JG. And I mean, we could do the math in our head real quick, right? But we want to make sure that we understand where the numbers come from. So MN is 30. So 30 is 1/2 of 20 plus X, right? Multiply both sides by 2. So 60 is equal to 20 plus X. So then X would be equal to 40. And I know we can do that in our heads, but we want to make sure, again, that we've got the method. Questions? So now on to a kite. So a kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. 2 pairs of consecutive congruent sides. And so unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. So it's a quadrilateral, it has 4 sides, but the opposites are not congruent, nor are they parallel. You just have 2 pairs of consecutive congruent sides. So, first theorem for a kite. If a quadrilateral is a kite, then its diagonals are perpendicular. If a quadrilateral is a kite, then its diagonals are perpendicular. And so when you put the diagonals in there, they don't always look like diagonals. But now when we look at this, it looks like a real kite, like you go flying with, right? Yeah. So the diagonals are perpendicular in a kite. And then secondly, if a quadrilateral is a kite, then exactly 1 pair of opposite angles is congruent. Exactly 1 pair of opposite angles are congruent. And when you're looking at those opposite angles that are congruent, it is going to be the 2 angles that are not between the congruent sides, if that makes any sense. So it's in this particular case, it's angle J and angle L. But angle J is not between 2 congruent sides. Does that make sense? Because JK and JM are not congruent. So we know that it's not going to be angle K and angle M because K is between 2 congruent sides and M is in between 2 congruent sides. So it's going to be the angles that are not in between the congruent sides. So hopefully that makes sense. We'll see when we look at the example. All right. So here is our kite. It is WXYZ. Okay, so angle X is 121, angle W is 73, and it wants you to find angle XYZ. Wants you to find angle XYZ. So they want to know this angle here. All right, so what is angle XYZ? How do we find it? What do we know about a kite? It has one pair of congruent angles. Where are those congruent angles? X and Z, because it is not in between the congruent sides. So this angle is 121. Right. So we got 121 plus 121. That's going to give us 242 plus 73, because that's the third angle. It's going to give us 315. And then the sum of all the angles has to be 360. So 360 minus 315 gives us 45, right? So angle XYZ is 45 degrees. Questions? You guys got questions? All right, last problem. Here's MNNOP. Oh, MENPQ. I don't know where I got those numbers from. MENPQ, and it says that it's a kite, and they want us to find NP. They want us to find NP, which is this side right here. So how can we find NP? How can we find NP? Well, we know NP is the same as NM. What do we know about the diagonals in a kite? They're perpendicular, so right here I can put a right angle. Right? And then when I put that right angle, what does this become? This is now a right triangle, right? And if I know two sides to get the third, I just have to use Pythagorean theorem. So 6 squared plus 8 squared is going to be equal to NM squared. 6 squared is 36. 8 squared is 64. That's going to be NM squared. 36 plus 64 is equal to 100. And then the square root of 100 is going to be NM, and so that's equal to 10. So this is 10, and if this side is 10, then this side is 10 as well. So NP is equal to 10. Any questions?